Bismillahirrahmanirrahim. The question before is, how do you prove these two triangles to be congruent? Said another way, how do we prove that triangle ABC is congruent to triangle DEF? Now recall that if two triangles are congruent, this means that all their corresponding sides are congruent and all their corresponding angles are congruent. While you can't go about proving that every single corresponding side is congruent and every single corresponding angle is congruent, that seems too laborious. So how do we go about proving that two triangles are congruent? Well, we should learn 5 different ways of doing so, and our job today is to learn what they are and familiarize ourselves with what they mean. Next time, inshallah, we shall do examples using these methods. The 5 ways of proving triangles congruent that we're going to learn are the following. They are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse-leg. Now, this is a short version of their names. They are again side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse-leg. The first 3 here are postulates. In other words, we're not going to be able to prove them. And the last 2 here are theorems. So we have 3 postulates and 2 theorems that we can use to prove triangles congruent. So again, we have a side, side, side triangle congruence postulate, and we have a side, angle, side triangle congruence postulate. We have angle, side, angle, triangle congruence postulate, and angle, 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 triangle congruence theorem, and hypotenuse-leg theorem. This last one is special because it has to do with the right triangles. Our job today is to familiarize ourselves with these 3 postulates and 2 theorems and to understand what they mean and how do we use them to prove triangles congruent. As you can see, it can get a little tedious to say the whole thing, so most of the time you use these abbreviations and then you say side, 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 angle, side, angle, 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 side, hypotenuse, leg. Now, we're going to think of these as conditional statements, and it's very important. Conditional statements help us organize our thoughts, and we should think of these in that pattern. Now, side, side, side triangle congruence postulate states that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Again, the side, side, side triangle congruence postulate states that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. In other words, if AB is congruent to DE like this, and BC is congruent to EF like this, and AC is congruent to DF in this manner, then these 2 triangles are congruent. Again, as I stated before, it's very important in how you state that. Here we would say triangle ABC is congruent to triangle DEF like this, and that would dictate which sides of these triangles are corresponding sides. In other words, it's proper to say triangle ABC is congruent to triangle DEF, and it would be incorrect to say triangle ABC is congruent to triangle DFE, for example. This would be a false statement. Side, side, side triangle congruence postulate states that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Now, if I ask a student, how do you know these 2 triangles are congruent, and they say side, 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 and they ask them, what does side, side, side mean? They are like speechless because they don't know how to articulate that. But we need to be able to articulate what side, side, side triangle congruence means. And you articulate it and you state it in the form of a conditional statement. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Now, side, angle, side triangle congruent postulate states the following. It states that if 2 sides of a triangle are congruent to 2 sides of a second triangle, and the included angle is congruent, then the triangles are congruent. Now, this is very important to understand properly. Now, what this states is that if 2 sides of a triangle, now we have 2 sides, see, this is side and side, there are 2 sides. Now, if 2 sides of a triangle are congruent, let's say AB is congruent to DE over here, and AC is congruent to DF over here, we're given that these 2 sides are congruent, and And we're given that the included angle, which is this angle over here, that's very important to understand this concept of included angle. See, these are the two sides, and this angle over here is the included angle. That is the angle that's between those two sides. These two angles over here are the excluded angles. Then these two triangles are congruent. Thus, in the side angle side triangle congruence postulate, we have side, angle, side, side, angle, side that are congruent in that order. So again, the side angle side triangle congruence postulate states if two sides of a triangle are congruent to two sides of a second triangle and the included angle is congruent, then the two triangles are congruent. By the way, once we've proven that the triangles are congruent, then we can assume that the remainder of the sides that are not mentioned and the remainder of the angles that are not mentioned are necessarily congruent by definition of congruent triangles. That is, once we prove these triangles to be congruent, we don't have to say that BC is congruent to EF, because that's what it means for two triangles to be congruent. Or this angle B is congruent to angle E over here, because that's what it means to be congruent triangles. Because as we learned before, corresponding parts of congruent triangles are congruent. So once we prove these triangles to be congruent, we can use CP/CTC to prove that the remainder of the corresponding sides and the corresponding angles are congruent. Now to angle, side, angle, triangle congruence postulate. Now this postulate states that if two angles of a triangle are congruent to two angles of a second triangle, and the included side is congruent, then the triangles are congruent. Here we have two angles, see, angle, side, angle. If two angles of a triangle are congruent to two angles of a second triangle, and the included side, previously we had the angle that was between two sides. Here we have the sides between two angles, and the included side is congruent, then the two triangles are congruent. So here we can say, let's say angle A is congruent to angle D, and angle C is congruent to angle F. And if the included side, which is over here, is congruent to this side over here, by angle, side, angle postulate, these two triangles would be congruent. So look, now these are postulates. The next two are theorems, which means that we can actually prove them. See, the way you prove these, the last two, is that you use the postulates to prove these theorems. But first, we must understand what they mean. Now, the angle side triangle congruence theorem states if two angles of a triangle are congruent to two angles of a second triangle, and one of the sides are congruent, then the triangles are congruent. Now let's understand this. We have angle, angle, side. This means that we're given that two pairs of angles are congruent. Let's say angle A is congruent to angle D, and angle C is congruent to angle F. But here, the side is the non-included side. See, it's not between the two A's. It's on the outside of the two A's. So in this case, for example, it could be like BC over here is congruent to EF. So here we have angle, angle, side, right? Angle, angle, side. So if two angles of a triangle are congruent to two angles of a second triangle, and one of the sides is congruent, now it doesn't matter which one it is, because if it was this side over here, it would be angle, angle, side in this direction. So it doesn't matter which one of the other two non-included sides is congruent. It works either way. So if two angles of a triangle are congruent to two angles of a second triangle, and one of the sides is congruent, then the triangles are congruent. This is angle, angle, side theorem. Okay, so far we have side, side, side triangle congruence postulate. We have side, angle, side triangle congruence postulate, angle, side, angle triangle congruence postulate, and angle, angle, side triangle congruence theorem. And finally, we have hypotenuse-leg. Now the last one is special, because this is the only one that has to do with right triangles. This is a special case. Now this one states that if the hypotenuse and one leg of a right triangle is congruent to hypotenuse and one leg of a second right triangle, then the right triangles are congruent. this theorem only applies to right triangles. If the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and one of the legs of a second right triangle, then these two right triangles are congruent. Here one of the hypotenuse is congruent and one of the legs is congruent, then these two triangles will be congruent like this. Okay? So these are the 5 ways we're going to learn how to prove triangles to be congruent. So if you're asked to prove 2 triangles to be congruent, you can say these 2 triangles are congruent because of side triangle congruent postulate, side triangle congruent postulate, angle triangle congruent postulate, angle side triangle side triangle, side triangle congruent postulate, angle side. So if you're asked to prove 2 triangles to be congruent, in your proof, you can simply say side, angle, side, angle, side, and hypotenuse leg. Now, this seems like a lot to remember, right? But they're not so bad, actually. Because the last one is, of course, a special case, hypotenuse leg. So we really only have 4 others to remember. The way I remember this is pretty easy. See, all of these are some combination of side and angle. You put these 2 alphabets together in any particular order, as long as you don't spell a bad word, if you know what I mean, like A as blank. You can put these 2 alphabets in any particular order, as long as you don't spell a bad word, and you got it. So you have side, angle, side, angle, side, but you don't have angle, side, you know what I mean. Or even the backwards of the following. You don't have side, you know what I mean. The last thing I wanted to bring to your attention is that one particular combination is conspicuously missing. You can't use angle to prove triangles congruent. For example, I have a triangle over here. This angle is congruent to this angle is congruent to this angle, and finally this angle is congruent to this angle over here. But clearly the triangles are not congruent. I simply taken this triangle and enlarged it over here. Even though the angles are congruent, triangles are not. So angle cannot be used to prove triangles to be congruent. So how do we prove triangles congruent? Side, angle, side, angle, side, be careful. And finally, hypotenuse leg. Next time, inshallah, we'll put these to work. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.